Hi there, and welcome to Ian's Engage channel. I'm Ian. In previous videos I showed how I temporarily laid and pinned my track to the XPS foam base layer. In this video I'm going to show how I soldered the fish plates between sections of track to both help keep it all joined together physically, which would also provide a better electrical connection between the pieces of track. So I suppose the first question is, why have I soldered some of the sections of track together? Well, the main reason was to keep the track physically connected together while I worked on it at the rear of the layout. Before I did this, as I manoeuvred the pieces of track into place, they kept coming apart, and once at the rear of the layout they were difficult to join up again because it was a bit of a stretch across the depth of the layout, and it also didn't help that I couldn't see properly in what I was doing. Now, I've certainly never soldered track together before, but it seemed like a good idea at the time, even though my soldering skills have always been somewhat, let's say, lacking. However, I firmly believe that the best way to learn is by doing when it comes to this hobby, so I persevered. As you can see from this clip, the track work at this part of the layout gets quite complicated with lots of points and crossovers. My plan had been to connect the track together on the workbench, then transfer the connected sections to the layout. Unfortunately, while only connected via fish plates, the pieces of track just kept falling apart as I transferred them. So, I decided to solder all of the complicated sections of track together, which made the whole process go a lot more smoothly. In this clip, I've already soldered most of the fish plates. I'm using the solid type of flux, which reminds me of earwax, and have spread it across the fish plate on the outer edge of each rail joint using a toothpick, after softening it with the soldering iron. I'm applying solder to the soldering iron as well as introducing more solder when I solder the joint. As you can see, it doesn't take long to make the connection, just a few seconds in fact. The advantage of doing this away from the layout is that you can pick the track up and rotate it, so that you have easy access to the opposite side of the track. It took me quite a few attempts to get any good using this method, which, other than being hopeless at soldering, I put down to initially not having the soldering iron turned up hot enough. However, by the time I'd made about 5 or 6 connections, I thought I was getting quite good at it. Once the joints had been soldered, I used my Pico 6-foot weigh gauge to ensure the tracks remained parallel and at the correct distance apart. Next I needed to fill in a gap in the track work using flexible track. First I made a rough cut, placing a long piece of flexible track next to the gap and marked it with a permanent marker so that it would be about 1 centimetre too long. Then I cut the rails with my Xuron cutters. In this instance it didn't matter which side of the cutters I used, as it was only a rough cut. Next I fitted one end of the track into position and overlapped the rails at the opposite end and used the marker pen again to mark the position, but this time much more accurately. Of course, you can't see this because my big hand is in the way. However, what you can see is that I'm wearing my magnifying helmet, without which none of this would have been possible. Once I was happy with the markings, I removed the track, counted back a few sleepers and used my utility knife to cut the sleepers away from the back of the track. I kept these so I can refit them when I lay the track properly. It was now important to use the flat side of the Xuron cutters to cut the track at the side I wanted to fit the fish plates to, as these would give a nice clean cut, as you can see from the footage. In this case, The cuts were actually perfect, but if they weren't, a small file could be used to dress the rail and take off any burrs. I'm fitting fish plates to the rails here using the bent rail method that so many people suggested in the comments of a previous video I shared. I then connect both ends of the track together and use needle nose pliers to pull the fish plates into the centre of the join. Yep, there's my big hand and now arm getting in the way again. Finally, I run my finger across the joint to ensure that the fish plates are properly located. It was now time to solder the fish plates to the newly fitted section of track, and this time I had a new product to try. I used DCC Concepts liquid solder flux and brushed it across the fish plates using a very fine paintbrush. I then used the same method as before by tinning the soldering iron tip and introducing extra solder into the joint. Of course, my big hand gets in the way again, so you don't see any of this, but the liquid flux definitely helped the solder flow a lot better than the earwax flux. See if we can see this join any better. Well, no, of course we can't. Again, doing things away from the layout allows for easy rotation of the whole track section for better access to the opposite side. You can now watch the back of my hand for a few more seconds as I solder the rails together. Here I'm checking that the rails have been properly joined and have a flat, even surface. You should of course do this before you solder them too. Next, I use the Pico 6-foot weigh gauge to ensure the tracks remain parallel and the correct distance apart again. The final thing to do was to check the electrical conductivity of the joints, which I did using a 9-volt battery and a Gauge Master track tester. As you can see, the track tester lights up red or green for a DC voltage depending upon the orientation of the power. I'll speed up the footage here as I check each of the pathways through the intersection, and you should be able to see that the light comes on, showing that there's electrical continuity throughout. Not only has soldering the track together resulted in a strong, solid piece of track work, but it should also help the DCC signal as it passes across track joins. It also means that I won't need to have so many dropper wires, as each individual rail is now effectively one long length of rail. The result of all of this soldering was one very solid, complicated section of track that was electrically sound, convenient to transport to the layout, and incredibly easy to fit into place once there. So, what do you think? Does anyone else solder their track sections together? If not, is there a reason why? If you do you use a similar method to what you're seeing here? And does it work? Oh, and how often do you leave a break to allow for rail expansion and contraction? Let me know. Okay, so that's about it for this update. If you've got any hints, tips, useful tools or techniques to pass on to a beginner in N-Gauge modelling, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks ever so much for watching. Hopefully I'll have another update on my progress very soon. Bye.